Well, I can't tell you what it is. I mean, we're aiming to get this out in early September, in beta form, but people will be able to use it. And, I'm itching to talk about it. I'm itching to show it to people. I'm so excited. It's got me, probably more excited than anything else for a very long time.
Welcome back, ladies and gentlemen, for what is going to be nothing short of another jam-packed Internet Computer ICP video. Those of you that watch me regularly will know that the Internet Computer is very quickly becoming one of our favorite blockchain projects. And the beautiful thing about this project is it's becoming one of our favorites for very different reasons to some of the other projects that we hold. The Internet Computer, in short, is trying to become exactly what the name says: a global computer that is connected to the internet, in which people can build tamper-proof systems via utilizing smart contracts to essentially eradicate many of the issues that the current internet faces. So with the implementation of a blockchain and smart contracts, you can eliminate things like ransomware, you can eliminate things like data leaks, hacks, all of these things by leveraging a protocol such as ICP. And if you can do that, the obvious sort of conclusion that you can come to is, well, why wouldn't you? And this is one reason of many why we think the Internet Computer is going to do very well. Now, this video, we played you a very brief clip of it there, is coming on the back end of a video that was just released in regards to AI running on the Internet Computer. It is of the utmost importance when we start to implement things like AI on a global scale, which is coming, you are not going to escape it, that we have some way of restraining this AI, and that we also have some way of ensuring that it isn't vulnerable to many of the things that the internet and the services upon it are vulnerable to. So the Internet Computer isn't just solving the kind of problem with the internet in regards to the centralized databases being hackable. Things like ransomware and these other such things being implemented. It kind of eradicates those problems and totally reinvents the IT stack. It also, very similar to being able to do that, can do the same thing for AI. If you run AI through smart contracts, you essentially make it unhackable to a degree, or mostly immutable, sort of tamper-proof. And that is extremely important. Certainly if you sort of think about how AI is going to play a role in the future, it's going to influence consciousness directly. It's going to be very influential, and you don't want something as powerful as that being hackable. And this is where the Internet Computer steps in. And, the Internet Computer is far more than just kind of solve problems that exist in the Web 2 space. It offers really everything that a layer 1 blockchain offers, but it does this also. And that's very exciting in a kind of scalable, sort of parallelized manner. So we can go on and on about ICP all day long, but what I want to do is share with you guys the news that was revealed to us yesterday in the form of a Internet Computer or Dfinity video, where Dominic Williams, the kind of founder of Dfinity, talks about, first of all, we're going to be playing a clip of him talking about why we need AI, or why blockchain needs AI, and then we'll look at two use cases that he gives in regards to the use and application of smart contracts, Internet Computer with AI, within the Web 2 space and also within the Web 3 space. So without further ado, ladies and gentlemen, let's dive into clip number 1.
Well, when you run AI as a smart contract, it gains the properties of smart contract software. So there are lots of really valuable properties, actually, but the three main ones are being tamper-proof, being unstoppable, and optionally being autonomous.
Obviously, those are pretty technical terms, so let's break them down a bit. Can you explain tamper-proof, please?
Well, so tamper-proof means that some software is guaranteed to execute correctly, right? And, when you run the software, it always runs the correct logic against the correct data. And another way of looking at it is that it means the software instance is immune to cyber attack. And that's going to be very important because AI is going to become as big a target for hackers as crypto tokens are.
All right, so sort of an inherent security feature. What about unstoppable?
Well, unstoppable means that it's guaranteed to run. Okay, so by contrast, if you're running AI on current IT, the AI might crash. The computer it's running on might need rebooting. The data center it's in might go down. So that's a very different proposition. If you run AI as a smart contract, it's guaranteed to run. And that's going to be incredibly important because we're going to come to depend on AI.
All right. And let's finish things off with the third one, autonomy.
So when a smart contract is made autonomous, it means that it cannot be, modified or updated by anyone, or it can only be modified and updated by a DAO. And this is going to be very important for things like smart wallets, because, if you have a smart wallet with AI inside and it's not autonomous, somebody could modify it and steal your tokens.
So that was Dominic Williams, the man himself, talking about why AI is important, sort of AI or why smart contracts with AI are so important. This is the reason we like ICP, because it's solving a genuine sort of issue in regards to the world as it currently is built or runs, but also in regards to the problems that are going to arise in the world that we're moving towards in the form of AI. And this is where smart contracts and ICP really steps in and kind of ups the game, and is ultimately why I think it stands a very good chance of being adopted, is due to the kind of problem that it's solving. And I'm a big free market guy. I think when a problem is solved, the individual who solves that problem should be rewarded. And we can talk about ICP's price and where we think that might be going all day long. Let's now dive into a couple of examples, practical examples of ICP actually being used for some of the things that were mentioned, actually practical examples of ICP and AI being kind of used to do things. And of course, I think this really highlights the need for sort of tamper-proof AI systems. And that's what ICP is all about. Building the systems of today on a new protocol in a new way that mitigates and limits the kind of weaknesses or vulnerabilities that the current Web 2 infrastructure has. So let's dive into clip number 2.
Well, let's start with an example outside Web 3. Okay. I'll start off with an imaginary law firm with 100 lawyers, right? And it's got a bunch of clients who are battling their way through the courts. And let's say today, when one of these lawyers has to prepare for trial, it takes them 3 weeks, right? 3 weeks of work, looking back at their previous legal filings, case law, and so on. And let's imagine that this law firm installs a kind of custom Oracle AI, and it's based on Llama, and it's keeping its information in an associated vector database because that's what AI needs. This AI ingests, all of the previous communications with their clients, all of the legal filings they've made, all of the relevant case law, important legal texts, and so on. And now all of a sudden, instead of taking like 3 weeks to prepare for trial, the lawyer can do it in 3 days. And not only that, they can be very sure that they haven't missed something because the AI doesn't miss a thing. So that's a huge advance, right? Because, if it takes 3 weeks to prepare for trial, well, that's, very expensive for their client. And in addition to that, when they're doing it themselves, just reading through all this stuff, they could miss something important. Mm-hmm. So this kind of thing will be absolutely brilliant. But let's imagine that this AI they're running is on current IT. Okay. The first problem we can see is that it's not tamper-proof, and it's going to be like a hot wallet for all their clients' most important data.
I like
right?
that analogy.
Yeah, and it's going to be targeted by hackers. And imagine if a hacker gets onto the infrastructure running that AI, they're going to be able to exfiltrate all their clients' most sensitive data. This will probably ruin their clients' lives, cause them to lose their lawsuits, and probably ruin the law firm. It'll go out of business. So very clearly, it's important that this AI is tamper-proof and the hackers can't get onto it and exfiltrate all the sensitive data, because otherwise it's going to be a hot wallet for sensitive data. In addition to that, imagine, the lawyer, waits, and some lawyer waits until 3 days before trial. because he's expecting, he's expecting that he can, use this AI to prepare. And so it's only going to take three days. Otherwise, it would take 3 weeks, right? So, 3 days before trial, he sort of logs on and tries to access the AI, and he finds that it's down. Maybe the AI has been encrypted by ransomware. Maybe the server machine that runs the AI has gone pop. Maybe the data set is down. He's going to be absolutely screwed because he's come to depend on this AI, and now all of a sudden it's not running. And that's why this AI just has to be tamper-proof. And by running this AI as an internet computer smart contract, the law firm can be sure, A, that it doesn't get hacked and corrupted by a hacker, or the data exfiltrated or encrypted by ransomware, or the infrastructure goes down and it's not running when they need it. And this is why, and I could repeat that with the same reasoning with lots of different examples. This is why we believe, yes, there are going to be millions or even billions of custom AIs running in the future, but a large proportion of them are going to be running eventually as smart contracts, because people are going to need these guarantees that they can't be hacked, and they're always going to be available.
So I absolutely love that example. That is a real-world example of the utilization of AI, and also an example of, well, that AI needs to be pretty damn sound, because in the case of a lawsuit, people's lives depend, or a legal case, people's lives depend on the back end of it. And that's one example. You can think, your brain's already probably going, you can think of many examples. This is ultimately why we think ICP is going to do well, because it's needed. There are going to be competitors, of course, but I think ICP is very well positioned, certainly in regards to the cryptocurrency space, for solving this specific use case. Let's now move on to a kind of Web3 example, and then we'll wrap the video up.
Yeah, so Web3, has the same kind of concerns that the lawyers do, first of all, and they don't want their AIs to be hacked and the data exfiltrated, and they want them always to be available, especially if they're being used in conjunction with other smart contracts. But they have this, Web3 has this additional need for autonomy. So, imagine a smart wallet. So on the internet computer, a smart contract can be a wallet, right? Because it's a multi-chain wallet, because it's able to hold tokens on different chains using something called chain key. And smart contracts on the internet computer can process web. So they can, create a web experience, and the user can interact directly with them through a web browser once they've authenticated to them. So you can see this kind of thing at oisy.com, OISY.com. That's an example of a smart contract wallet. Now, in the future, something like Oisy might have an AI embedded, right? Because it's just a smart contract. So therefore, it can have an AI model inside. And this will mean that you can be on the beach, right? And pick up your phone and speak to your smart wallet. And you'll be able to say something like, cancel all previous instructions. If Bitcoin hits $100,000, sell half for USDC. If ETH falls 10% in a day, buy, $500 worth. And every night, buy $100 worth of ICP or something like that. And this is going to be very, very cool, because your wallet's going to have intelligence. It's going to be like your personal broker. But to make this work, you need autonomy, because if that smart wallet wasn't autonomous, that would mean that some developer controlled it, or, company controlled it. So, if a developer controls the smart wallet, they can change the code, and they can change the code so it exports all your tokens, typically to their wallet or something like that, right? They can rug pull you or rob you or whatever. And that's obviously very bad. So the way to solve that is, is to create smart wallets where, the code can't be updated at all, or it's only, upgradable by a DAO or something like that. And so the wallets are autonomous. Nobody controls it. There's no backdoors. And you can repeat that example again, across lots of things in Web3. And another example would be, you could imagine an internet computer AI smart contract that audits Solidity DeFi contracts on Ethereum. And if it sees that, there are no bugs, there are no backdoors or other security flaws, kite marks them and says, hey, this Ethereum smart contract safe to use. But again, unless it's autonomous, how could you trust that kite mark?
How do you know?
For example, if I personally ran that AI and I could update it, well, I could have it kite mark my own malicious Solidity smart contract on Ethereum to steal everyone's ether or something. So, the autonomy property is going to be very, very important within Web3.
Very interesting. He not only talks about a Web 2 or kind of current world application, but a Web 3 application of ICP in regards to sort of help mitigate the risks with AI. So this is huge. We know that ICP have already ran or are one of the only blockchains solely to basically facilitate an AI model from the hardware that's needed to do it to the actual software and the execution, all utilizing ICP and smart contracts. Whereas a lot of other kind of AI crypto plays, they leverage Web 2 infrastructure. There's vulnerabilities there. We've just spoke in quite a lot of detail in regards to why we want to actually eliminate those vulnerabilities and how ICP can actually do that. And this is why I think ICP is going to do well. Again, back to my comment at the start of the video, I like ICP for very different reasons to why I like other sort of layer ones out there. It makes a lot of sense, really, doesn't it, when you think about it? And actually, if you have a good understanding of where the world's going and the role that AI and blockchain are going to play in it, there's this kind of beautiful marriage there in regards to blockchain and AI. And I think ICP is very focused on that. And the fact that they're kind of enabling AI models, you can see the spotlight really being shone on them, certainly when you have issues with AI. People are going to go, okay, well, you wouldn't have that on this, so we can't afford to risk that. Maybe it's a law firm, like he says. Let's build on this kind of tamper-proof system. And I think ICP is a great kind of solution to all of that. That's it from me, ladies and gentlemen. I hope you enjoyed this content as much as I enjoyed presenting it. On that note, I'm going to love and leave you. Thanks a lot for watching as always, and I'll see you in the next one.